Hello everyone, this is Shweta here and this is my another video for the topic understanding quadrilaterals. So in this video we will be covering the concept of parallel and transversal line which you have already studied in grade 7, but as these concepts are going to use in this chapter, so I am going to just do a recap of these concepts. Then we will study about quadrilateral and their types, and in this video I will be covering only the properties of trapezium, kite and parallelogram. Rhombus, rectangle and a square will be in my next video. And then we will see the properties of parallelogram. So parallel line and transversal line. Now if you see the figure which is given over here, L and M are parallel lines. And these two parallel lines are cut by a transversal line which is T. So we have already studied in grade 7 that when two parallel lines are cut by a transversal, then each pair of corresponding angles will be equal in measure. Now here what are the corresponding angle? So corresponding angle means, as the name suggests, corresponding means their position should correspond to each other. So if I take here angle 7, now you see angle 7 is above the line L and it is on the right side of the transversal. So same way the corresponding angle for angle 7 will be angle 8, because angle 8 is also above the line M and it is on the right side of the transversal. Okay. Similarly angle 1 and angle 2, they are also corresponding angle. Now angle 5 and angle 6, they are also corresponding, and angle 3 and angle 4 also are the corresponding angle. So if two lines are cut by a transversal, then each pair of corresponding angles will be equal in measure. Now next, if two parallel lines are cut by a transversal, then the pair of alternate interior angles will be equal. Now first of all, what are the interior angles? The angles which is between these two parallel lines. So if you see between these two parallel lines L and M, the interior angles are angle 1, 3, 6 and 8. Okay. So when two parallel lines are cut by a transversal, the alternate interior angle will be equal. Angle 1 will be equal to angle 6 and angle 3 will be equal to angle 8. The alternate interior angle will be on the either side of the transversal. Okay, one is on the left, other will be on the right, and they will have the different vertex. Okay, now different vertex means if you see for angle 3, the vertex is here, and for angle 8 the vertex is here. So angle 3 and angle 8 are one pair of alternate interior angle. Similarly angle 1 and angle 6 is the another pair of alternate interior angle. Okay. Now if two parallel lines are cut by a transversal, then each pair of interior angles on the same side of transversal are supplementary. Now we have already know that interior angles are your angle 1, 3, 6 and 8. But here it is given pair of interior angle on the same side of transversal. So same side of transversal, if I see here angle 1 and angle 8, they are on the same side of the transversal. Both are on the right side. Okay. So their sum will be supplementary. Same way angle 3 and angle 6, they will be also supplementary. Supplementary means their measure will be 180 degree. So these are the concept of parallel line and transversal line which we are going to use in this chapter. Now next we will see what is a quadrilateral. So the word quadrilateral comes from the Latin word quadri. Now quadri means 4 and the lattice means side. Now quadrilateral is also known as tetragon. Okay, where tetra means 4 and gon means angles. Okay, so quadrilateral is basically a closed figure which is made up of 4 sides. So if you see here, it has got 4 sides: A, B, B, C, C, D and D, A. Okay, so these are the 4 sides. Then they have 4 vertices also. So vertex A, B, C and D. It has got 4 vertices. It has 4 angles: angle A, angle B, angle C, angle D, and it has got 2 diagonals: AC and BD. Now diagonals are the line segment which join two non-consecutive vertices. So for vertex A, the non-consecutive vertex is C. So if you join A and C, AC will become a diagonal. Similarly, BD is a diagonal. Now there are different types of quadrilateral. So if you see, these are the family of quadrilateral. Okay, so and if you see each figure, all the figures are having four sides. Okay, so different type of quadrilaterals are kite, trapezium or trapezoid, parallelogram, isosceles trapezium, rectangle, square, rhombus. They all are quadrilaterals because they all have four sides, four angles, four vertices and two diagonals. Okay. Now next we will see trapezium. Trapezium is also known as trapezoid in some of the countries. A trapezium is a quadrilateral in which one pair of opposite sides are parallel, but the other two sides of it are non-parallel. So if you see the figure here, I have put the arrow mark. This arrow mark tells that the AB and DC are parallel sides. Okay. Why I am telling parallel? Because if you extend these two sides, okay, they are never going to meet. But AD and BC, they are the non-parallel sides, because if you're going to extend it further, okay, if you're going to extend it further, they are going to meet. And moreover, if you see this gap, it is not same throughout. Here the width is more, then here the width is less. Okay, so a trapezium will have only one pair of parallel sides. Okay, and since AB is parallel to DC here, so we can see that BC will become the transversal. Okay, if AB is parallel to DC, then I can see BC is the transversal. And just now we have seen when two parallel lines are cut by the transversal, then their interior angles on the same side of the transversal will be supplementary. Same way, if you take AB parallel to DC and if you take AD as the transversal, then angle A and angle D will be supplementary. Okay, if you take AD as transversal, then angle A and angle D will be supplementary. If you take BC as a transversal, angle B and angle C will be supplementary. Okay, supplementary means their sum will be 180 degree. Now next is isosceles trapezium. Now isosceles trapezium, you have already studied isosceles triangle, right? In the isosceles triangle, what you have seen, two sides of the triangle will be equal. Same way in isosceles trapezium, the non-parallel sides will be of equal measure. Now, if you see this figure here, AD and BC are the non-parallel sides. So, if these non-parallel sides are of equal measure, when I say equal measure means, suppose if AD is 3 centimeter, BC is also 3 centimeter. So, in such case, we can say the trapezium is a isosceles trapezium. Okay. So, here AD is equal to BC and AB is parallel to CD. Now, kite. A kite is a quadrilateral in which two pair of adjacent sides will be equal. So, if you see the figure here, ABCD is a kite where AB and AD are equal measure. Both are adjacent sides. So, AB and AD are equal measure. Same way BC and CD are equal measure. So, it will have two pair of adjacent sides which will be of equal measure. Now, properties of kite. So, first we have already seen the adjacent side will be equal measure. So, AB will be equal to AD and BC will be equal to CD. Now, it is symmetrical along the longer diagonal. Now, what does it mean? Now, symmetrical along longer diagonal, if you see there, it has got two diagonals AC and BD, and it is very clear that AC is the longer diagonal. So, if you fold this kite along this diagonal AC, you will see that these two triangles will overlap on each other. Okay, the triangle ABC and the triangle ADC will overlap, means they will have a complete symmetry. Now, the diagonals of the kite will intersect at right angle. Right angle means at the intersection point they form 90-degree angle. So, if you see here AC and BD, they are intersecting at point O, and you can see this angle formed here is 90 degree. Okay. Moreover, the longer diagonal, which is AC, it will bisect the smaller diagonal BD in two equal parts. Bisect means they will divide in two equal parts. So, OB will be equal to OD. Okay. Bisect means it will get divided in two equal parts. So, OB will be equal to OD. and the two angles which will be formed where unequal sides meet are equal in measure. So unequal side means AB and BC are unequal side and they are meeting at point B. Same way AD and CD are the unequal side, they are meeting at point D. So angle B will be equal to angle D. Clear? So now we will see parallelogram. A parallelogram is a quadrilateral in which both the pair of opposite sides are parallel. So in this parallelogram, the opposite sides AB and CD are parallel and AD and BC are parallel. Okay, so the opposite sides are parallel. Now we will see some of the properties of the parallelogram. So the properties are opposite sides are equal. So AB is equal to CD. Similarly, BC is equal to AD. And then opposite angles are equal. So angle A is equal to angle C. Similarly, angle B is equal to angle D. Now we will see how we can say that in a parallelogram, opposite sides and opposite angles are equal. So if you remember, you have already studied in grade 7 congruency of triangles, right? So what I am going to do, I am going to take a parallelogram and I am going to divide it in two triangles. If you see here in the parallelogram ABCD, I have joined the diagonal BD. Okay, so the parallelogram is getting divided in two triangles. One of the triangle is ABD, another is CDB. Now I'm going to prove these two triangles as congruent triangle. And we know that to prove two triangles as congruent, we need at least three criteria, isn't it? So let's see one by one. So in triangle ABD and CDB, first thing angle 1 is equal to angle 2. Now why? Because AB is parallel to CD and if you take BD as the transversal line, then the alternate interior angles will be equal. Same way, if you take AD and BC as parallel line and BD as the transversal, then angle 4 will be equal to angle 3. Again, they are alternate interior angles, so they will be equal. And the third criteria is BD is the common side for both the triangles. If you see, BD is the common side. So now I got my three criteria. So based on this, I can say these two triangles are congruent. But congruent using which criteria? So if you see here, this is your angle, okay, angle, this is side and this is again angle. So we can say that these two triangles are congruent using ASA congruency criteria. And when I prove that two triangles are congruent, then their corresponding parts will also be equal. Corresponding parts means their corresponding sides, their corresponding angles will also become equal. So I can say that the opposite sides AB will equal to CD because AB and CD are the corresponding side of both the triangles. Similarly, BC will be equal to AD because they are also the corresponding sides. Okay. Now the corresponding angle. If I see triangle ABD and CDB, angle A corresponds to angle C. Okay, so they will also be equal. Similarly, angle B will also become equal to angle D. And reason will be corresponding part of the congruent triangles are equal. In short, we can say by using CPCT. Okay. So now we will see some more properties of the parallelogram. So another property of the parallelogram is the diagonals of the parallelogram bisect each other at the point of intersection. So if you see here AC and BD are two diagonals, they are intersecting at point O. So the property says that the diagonals are getting bisected. Bisected means they are getting divided in two equal parts. So I can say OA will be equal to OC and OB will be equal to OD. Now again I am going to show that why the diagonals are getting bisected and they are equal. Okay. So again I am using the concept of congruency of the triangle and I am going to take two triangles, triangle AOB and triangle COD. Now if you see here in both the triangles, angle 1 is equal to angle 2. Now why? Because we know that in a parallelogram opposite sides are parallel. So AB is parallel to CD and AC is the transversal. So we can say the alternate angles will be equal. So angle 1 is equal to angle 2. Now similarly, Angle 3 will be equal to angle 4 because again AB and CD is parallel and BD is the transversal. So again the alternate angles will be equal, and the third one AB will be equal to CD because we have already seen that opposite sides are equal, right? Just now we have proved that in a parallelogram opposite sides are equal. So again I have got my three criterias. So I can say that the triangle AOB and COD will be congruent. And again the congruency criteria will be angle, side, angle. Okay, ASA. So if both the triangles are congruent, then I can say that their corresponding parts will also be equal, right? So OA will be equal to OC and OB will be equal to OD. And the reason is corresponding part of the congruent triangles are equal. Clear? Now the last property of a parallelogram is the adjacent angles in a parallelogram are supplementary. Now what is the meaning of adjacent angle? So the angle which is next to it. So if I take angle A, for angle A, my adjacent angle can be angle B, it can be angle D. So this property tells that the adjacent angles are supplementary, means angle A plus angle B is 180 degree and angle A plus angle D is also 180 degree. Similarly, angle B plus angle C will be 180 degree, angle C plus angle D is also 180 degree. Now we will see why the adjacent angle will be supplementary. So we already know that in a parallelogram, the opposite sides are parallel, right? So I can say AB is parallel to CD. So when I say AB is parallel to CD and if I take AD as my transversal, then what will happen? Angle A and angle D, they will be the interior angle on the same side of the transversal, right? See what I am doing? I am going to extend these lines, okay? It will be very much clear to you that now CD and AB is parallel and AD is the transversal. So you can see these two are the interior angle on the same side of the transversal. Both are on the right side, isn't it? So their sum will be supplementary. So angle A plus angle D will be 180 degree. Now similarly, the AB and CD if I take parallel and if I take BC as the transversal, then again angle B plus angle C will be 180 degree. Now similarly, if I take AD and BC as parallel and this AB as the transversal, then angle A plus angle B is the interior angle on the same side. So they will be also supplementary. And in the last, AD parallel to BC, and if you take CD as the transversal, then angle D plus angle C will also be 180 degree. Okay, so that's all for today's class.